Hello guys, I just was putting together a new computer system with motherboard, CPU, and memory, and I thought I would create a little recording of it just in case I ever wanted to go back and see what I did. The first step, of course, is to get your CPU mounted, which I already did. This particular chip has a slide-in socket that you lock down with a clamp, which I already have done. This clamp right here comes up to loosen it, and then you lock it down. Now I had to get it positioned exactly right and flush, and so now that I've locked it down, I don't want to unlock it again. But the next step is I'm going to mount this heatsink on top of the CPU. It's designed to take all the heat away from the CPU, which runs very hot. It's the busiest piece of the system, so it's very important to have a good heat sink whenever you install or build a system like this. So the motherboard by default comes with these little clamps that are designed for a different type of heat sink, and I decided to use one that requires just the screw holes themselves to go into, and so we are going to remove the default brackets that come with the motherboard. So I just got done loosening the two screws, and I'll show you what that looks like here in a second. So this is an example of one of the brackets that's being removed, and we're about to remove the second bracket. And always, whenever you're working on a system like this, make sure you're using anti-static surfaces, and make sure you yourself are grounded properly so that you don't introduce any kind of electrical shock to some of these parts that might be sensitive to it. A lot of them are hardened and tested for those kinds of things, but you never know. If you were to accidentally just touch the wrong spot on the board, and you might transfer a tiny bit of current to something that can't handle it, you can actually cause a problem, and then you'll never know where the problem's coming from. You'll just have a system that's not working properly. So yeah, we always have to be very careful. Whenever I'm touching the board, I try to always use the edges. Anything that's plastic or silk screened, dark in color, like you can see most of this board is usually a pretty safe area to touch. It's the exposed metal that you want to try to stay away from if at all possible. So I've exposed the 4 mounting points. I've gotten all 4 screws out and 2 brackets, so I make sure I don't have any leftover parts lying on the board. Okay, now it's very important as I mount this heatsink that I get it exactly lined up with the chip. And I want to have my cable in such a way where it can easily get to the port where it has to connect. Now, this particular motherboard has a fan port that's right up here near the top. So I think there's enough length in this that I could probably mount it either of 2 ways. Heatsink is back on the CPU, nice and snug how we want it, and now we have even more play with the coil with the fan, so I'll just curl it to kind of take the space out, and yeah, I think this can go like here, and I will double check that in a minute, but it does say CPU fan for that port, so I will double check it with the book later. Alright, so the third most important component of a computer after the motherboard and CPU is the memory. And this is kind of like your workspace. So whenever you're loading applications, programs, things up on the screen so you can work on them, they usually live inside the memory. The memory is the key area where data is moved in and out of in a writable way so it can be updated. So it's very important with memory to try to handle it from the the dielectric, not the conductors, and so that way you don't transfer any static electricity to the chip. Also, these chips will be notched, so they can only go in one way. So you need to kind of look at the notching on the motherboard and then figure out how this lines up. So for me, this is like this. Now, I believe that the configuration that I want is the second slot. So we're going to lower the arming mechanism on the second and fourth slots. And before I lock these in, I'm going to double check it, but I believe that this is how I want my chips to go in. So, and actually I think I will lock it. So what you do is you press down firmly until it snaps like that. That locks it in place. And now I'm going to take the second one, and I went into the 2 position, and now I'm going to go into the 4 position, and then I'm going to double check in the book and make sure that that's where they need to be for the optimum, the fastest performance, which is absolutely what I want. So, okay, this is the 4 slot, and I'm going to slide this down into these guides, make sure my notch lines up, and then I'm going to press down firmly until it snaps in and the lock is in place. All right, so now we have a fully loaded motherboard with CPU, heatsink, and memory, and this is called the Rogue Strix board by Asus. So it's a pretty fast gaming board. I'm going to be using it mainly for gaming, but also other applications. So I'm going to be giving this a test drive a little bit later and make sure it runs properly.
5 minutes later.
As you can see, I've got a really old case from a computer that I probably first built like 10 years ago. But every time I've upgraded the core or the guts of the computer system, I haven't had a reason to necessarily replace the case. It basically just is a holding bin for all the things that I'm doing. So things like the floppy drive and the CD-ROM drive, I don't even really use those anymore, but they take up a space and they keep it from just having an ugly hole there, and it already is the wrong color anyway, but that's fine. What I really want to show you is how to take out the existing core guts of a PC system and replace it with a newly built setup. So if I tilt this towards the camera, you can see that the main components in the PC are the power supply, which drives everything, and typically there's a large connector going to the motherboard that supplies the motherboard power. Then you have other power cables that are designed to go to peripherals like CD-ROMs, floppy drives, and hard disk drives. So right here I have 3 SATA drives. SATA drives are easier to connect because they just use a very simple data cable and 1 power cable. So I can have, you know, as many of these enabled and connected as I want. Right now in my old system I only had this 1 drive connected because I think it was the only one that I needed. But as you can see, the existing motherboard that's in place has a CPU with a heatsink on it, a lot smaller than the one I just built in the previous video. And it also has 2 memory chips that are here in the slots next to the CPU. And it also has 1 large video card, which is a PCI slot, and it has an HDMI port on the back of it, so I can use an HDMI cable and HDMI monitor. So what I'm getting ready to do is unplug anything that's connected to the motherboard, and then pull out this video card, so I'm going to reuse in the new system. Then I'm going to remove all the screws that are holding this motherboard down to the base of this cabinet that it's in. And then I'm going to slide in the new motherboard, the one that I just built in the previous video, and I'm going to mount it with the same screws. Then I'm going to reinsert the video card to that motherboard. I'm going to connect the power to the motherboard, and then any data cables that are going to like disk drives, they'll also be connected to the motherboard. And that will be the majority of what has to be done to get this computer ready to come up with a bigger, better, faster motherboard, CPU, and memory core combination. Okay?
5 minutes later.
And I've already taken out the video card, which is right here. It's a decent card that we're going to reuse again in the new system. And I've taken out all the screws that keep the motherboard inside. So now you can take it and basically lift it out and slide it out. And, oh, I did miss 1 little cable. So basically all these cables that are hanging out over here up to this part are like the controls, like buttons for power and reset, or maybe LEDs that show you when a hard drive is being accessed, things like that. So these are all your little system panel connectors, and they will go onto the new motherboard. But look how tiny this thing is. This is the motherboard we're replacing. It's actually pretty small form factor compared to the new one that we're going to put in. And you'll notice motherboards, they have all these interfaces for your LAN, audio, DVI. This is an older video connector, keyboard and mouse. The new one doesn't even have this or this because it's an upgraded version of the motherboard. So I'm going to take this guy and set it aside. I'm not even that worried for, you know, electrostatic care because it's an old motherboard. I'm pretty sure I'm not going to use it again. But notice that I keep these 3 things together: the motherboard, the CPU, and the memory. Because typically when you upgrade your motherboard, almost always you are going to upgrade the CPU and memory at the same time, because these 3 things are usually rated to be matched up with each other. It's very unlikely you can reuse some memory on the new motherboard, because a lot of times that motherboard is rated for much higher, faster memory. So it's better when you upgrade the motherboard, you might as well upgrade the CPU and the memory at the same time. So I keep these 3 together. So if I ever want to build another smaller system with this, I'll just use this as a core bundle, and then I'll add other things around it like a video card or whatever else I need. So I'm going to set this aside. And we are now going to bring into play the new motherboard memory and CPU, which is a lot newer, faster, better. The memory actually lights up when it's on. It's pretty cool. I'll show that to you later. And before I insert that into the case, I just want to show you that every case, or most cases, is designed like this, where you have these little mounting screws. You can put the screws in wherever you want, but I have the configuration that's for the type of motherboard that I always use. So the motherboard will lay on top of those screws, and the screws will hold it in, and the I/O ports will slide up against this end over here, so that you'll have access to like the HDMI and the audio and all those kinds of things. So you have your power up here that's driving everything. You have discs and external devices here that will plug to the motherboard. The motherboard goes here. This is the main power that's going to power the motherboard. This is called the 6-pin power that's often used for other motherboard functions, usually on the top left corner of the motherboard. And then the other power is for the SATA drives and other things. And that's pretty much it.
5 minutes later.
A new motherboard has now been installed, and by the way, whenever you take out an old motherboard, always look to take out the little faceplate that's on the I/O, because each motherboard's I/O port is different. So some of them come with an external plate that you put in, and some, like this motherboard, have their own built into the motherboard, so I didn't need a plate at all. But basically, if I rotate this up, you can see that the new motherboard is now installed. The black motherboard, this is the I/O port for that guy. There's the heatsink that we mounted onto the CPU. Notice that the power's connected. We've got our new memory here, 2 slots. The video card's been inserted back in and mounted. Our SATA cables are all connected. And the very last thing I have to do, which is the trickiest part, is connecting all these little pigtails. You have like one for the speaker, one for reset switch, power switch, hard drive light, and almost every motherboard will come with its booklet, and inside the booklet you need to flip to the page that shows you where to connect all these little cables. I don't know if you can see it really good, but there's always going to be like, oh, here's the header, it's located in the bottom right corner of your motherboard, and these are all the things that connect to it, and it's got everything from speaker to hard drive light to power switch to reset switch. So that's kind of the last little painful part that we have to do one by one, and it also helps in situations like this to have like a little work light, and that way you can shine your light down inside and make sure that you can see the pins that you're connecting to, and make sure you get exactly the right pins, because it's very easy to be like shifted over 1 or 2, and then you won't get suddenly your speaker won't work, or you hit the power button and nothing comes on. That means that you didn't connect one of your little external pigtails to the right pins. So I'm going to pause the video again so you don't have to watch me struggle with connecting those cables, and the next one will show it actually up and running.
5 minutes later.
It is so quiet. I almost can't even tell that it's on.